In this lesson, we're going to add and subtract radical expressions. Before we can do that, we need to define what are like radicals. Like radicals have the same root and the same radicand. And remember, the radicand is that number underneath the root sign. And what's important about like radicals is that you can only add and subtract like radicals. So in this next problem, we see 3 radical 12 plus radical 27. The way these radicals are right now, we cannot add them because the two radicals are different. Both have the square root, but the radicands are different. So before we can add these, we need to simplify each of the radicals. Now 12, the perfect square in 12 is 4, so 12 can be rewritten as 4 times 3. 27, 9 is the largest perfect square, so we can rewrite that as 9 times 3. So simplifying, we have the 3 on the outside. The square root of 4 is 2, so the 2 comes out and multiplies the 3, and then the 3 is left over, so it stays underneath the radical. Plus, square root of 9 is 3, so that 3 comes out of the radical, and there's the 3 left over. So the 3 times 2 is 6 radical 3, plus now 3 radical 3. Now, the two radicals are like radicals, so you can add the 6 and the 3 together for 9 radical 3. Now, the next problem's a little bit different. Here we have to remember our order of operations, and you're going to have to multiply the radical 2 and the radical 10 first. So radical 2 times radical 10 is radical 20, and now you can add that to 3 times radical 45. Now these are not like radicals yet. We need to do some simplifying. 20 is 4 times 5. 45 is 9 times 5. So square root of 4 is 2. The 5 is left over. It stays underneath the radical. Keeping this 3 on the outside, the square root of 9 is 3, so that 3 is going to come out and multiply the 3. The 5 is not a perfect square. It stays underneath the radical. So we now have 2 radical 5 plus 9 radical 5. The two radicals are the same. We have like radicals, so add the 2 and the 9 together for 11 radical 5. Now this next problem has fractions in it, but let's not panic. Again, we need to simplify radical 32 and radical 18. 32 is 16 times 2 if we're looking for the largest perfect square. 18 is 9 times 2. So the 5/4 is on the outside. It stays on the outside. Square root of 16 is 4, so that 4 is going to come out and multiply the 5/4. And if you want to write that as 4 over 1 because you're dealing with fractions, that's fine. The 2 is left over. It stays underneath the radical. The next term, we have 2/3 times square root of 9 is 3, so that 3 comes out. You can put it over 1 if you want. The 2 is left over. It stays underneath the radical. So here we can see the 4's cancel. Here we can see the 3's cancel. So you're left with 5 radical 2 minus 2 radical 2. We now have terms with like radicals, so you can take the 5 minus the 2 for 3 radical 2.